the game?
Okay, so we're going to continue our study of polynomials.
Find the zero.
Find the zeros. Okay? And finding the zeros, what that means is finding the x values where the function equals 0. So there are two different ways that you can do this. One way, which I'm sure will be your favorite way, is you can do it algebraically.
Yeah.
So you take the function and set it equal to 0, and then you solve it.
What about...
So what do you think I need to do to solve that?
Quadratic.
I can't use the quadratic formula because that's a cubic. Right,
Cubic
but if I
formula.
factor out an x first,
Can you do that?
Yeah.
No, I'm talking about cubic formula.
now I do have a quadratic, okay? So since each one of those terms had an x in there, I can factor out an x from every term. And then what's left is a quadratic function, okay? So you can do that on your calculator. It'd be fun if you were able to do that just by factoring it.
Nobody likes it.
Okay? Okay, when you do the quadratic formula on x squared minus x minus 6, you get x could equal 3 or negative 2. But there is another answer. What's my other answer?
0.
0, good, because when I factor like this, what I'm saying is, since this times this equals 0, one of these two things has to equal 0. And if it's this one right here, then that means just plain old x equals 0. If this thing equals 0, then that's where you get the 3 and the negative 2. Okay? So that was a cubic. How many answers did I have? 3. Huh. You could also do this by graphing. And it takes a little bit more time, but it takes less thinking. Okay? Because the calculator basically does the work for you. So you start out by graphing your equation, which was x cubed, what was it? Minus x
squared.
minus x squared plus minus 6x. Okay, then if you look at the graph of that function, how many times does it cross the x-axis? 3 times. Where does it cross the x-axis? Negative 2, 0, and 3. Okay, so
It's
you,
hard to see on the window.
right, and so if you can't see what the exact thing was, there is a built-in feature in your calculator. If you go second trace, then the second option is 0. So if I wanted to find this 0 right here, name a number to the left of that.
Wait,
I'm going to go negative 3.
second trace what?
Second trace 0.
And then you can do 0.
And then I want to name a number to the right of that, so I can do 0. And then my guess is negative 2. And then it says, yeah, hey, you're right, x is equal to negative 2. So if you can't see exactly where it crosses, if it comes out to be some sort of a decimal, you shouldn't just look at the graph and assume that it crosses out a whole number. You need to use its 0
So what one do you do?
well, I would like you to be able to use both of them depending on which one is easier. This is a really easy one to factor and solve.
Yeah.
So ideally you would see that and just go bam, 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 just like we did 3, negative 2, 0.
Can I do another one like that?
Like that.
Well, yeah, I want to be able to test it. Is it just the opposite of what's on the inside of the parentheses, or is that just a computing?
No, it's the opposite of what's inside.
We learned that last year. Oh, did we? Don't speak to me, please. You're being condescending right now. Stop using that tone.
Okay, sometimes functions can have multiple zeros at the same spot. So for example, if I start with x minus 2 cubed times x plus 1 squared, if I take and set that equal to 0, x minus 2 cubed means what? 3 of them.
Yeah.
So it means x minus 2 times x minus 2 times x minus 2. And x plus 1 squared means 2 of those. X plus 1 times x plus 1. So then you could say that your answers are, what would my answer to this one be? 2. 1. So this one is also 2. And so that one is 2, negative 1, and negative 1. But it's silly to write all of those out that many times. So what they do instead is they say that your answers here would be 2, and it's called multiplicity, which you can abbreviate, 3, and negative 1, multiplicity 2. Okay? So 2 multiplicity 3 means that it really has 3 zeros right there at 2, and negative 1 multiplicity 2 means it has 2 zeros at negative 1.
Can you just do like the number of parentheses? And
We did this last year. What?
you do like 2 and 3.
Yeah, you could do 2 and 3. Okay, so let's take a look and see what that looks like when you graph it, so that you can recognize from the graph multiplicity. So if I go x minus 2 cubed, and then what is it, x plus 1? Okay, and then I look at the graph. Here it is at minus 1. Can you see why that has a multiplicity of 2? Because it goes up and touches it and then comes right back down. And this shape right here, Tucker and Drew, this shape right here is what kind of a graph? If I just looked at that part. It's a parabola, and parabolas are what power? 2. And so since this is the shape of a quadratic, that means that hitting it right there has a multiplicity of 2. This one over here has the shape of what kind of function? A cubic, and that's why it's multiplicity 3, because where it crosses right there, it has the shape of a cubic function. So you can recognize those a little bit from the graph. Okay?
Okay, wait a minute. When you go back to the where you were writing up, like Rocktober, October, is that you?
Better.
I don't get it like Rocktober.
That's what was it?
Why is there an R there? What's the R there for then?
October, dude.
Okay.
Yes.
Okay, so we can also, of course, do word problems with polynomials. Yep. Did we design a box yet in this class?
No. Sir,
Are you sure?
yeah. We get to make our own boxes. Actually, we did do something like this.
Didn't we?
Yeah. No, never. Yeah, we didn't. No, we didn't do this.
Okay, so we're going to use this to design a box.
We can do this.
I feel like we did this before. Dixie Packaging Company has been contracted to make boxes with a volume of approximately 484 cubic inches. Squares are to be cut from the corners of a 20-inch by 25-inch piece of cardboard and the flaps folded up to make an open box. What size squares should be cut from the cardboard? So yeah, I think we did this before. The volume of this box after I cut out the squares and fold up the sides will be what? What? Not 20x, because this whole thing will be the, not minus x, 20 minus 2x. Because I need to take away a piece there and a piece there. So that will be one dimension. What will be the dimension this way? 25 minus 2x. And when I fold those up, what will the height of the box be?
2x.
No, because I'm just folding up the side x. Okay? And what do we need that to equal?
7. I don't know.
No, that would be a box with no
484.
margin. 484. So I'm going to take this function right here, 20 minus 2x times 25 minus 2x times x, set it equal to 484, and solve. How are you going to solve that? I could FOIL all that out, but that would suck, so we're not going to do that.
You could just take stuff
I'm
out.
going to plug it into the calculator, but to plug it into the calculator, what do I have to do first? Set it equal to 0. So I have to subtract 484 from each side first.
So would it just be minus 44?
Yep, so it'd be minus 484 equals 0. Okay? And then I'm going to graph that. And what am I looking for? What am I trying to find?
0.
Hey, girls.
Area.
What am I trying to find?
Volume.
Nope.
Area.
On my graph, what am I looking for?
Where it crosses the...
Good, where it crosses the x-axis. Okay, now when I graph this right away, I might not see where it crosses. Oh, yep, there's one and there's another one. Okay, good deal. So I just need to find. What's that? I got them. I feel like I'm pretty good there. Okay, so we could zoom out and make sure. So if you zoom out a little bit,
That's no better.
doesn't really, yeah, that's kind of a mess.
So where
So we're
does
just
it
going to
cross?
go with, okay, so how do we find out where that crosses?
You go do the zoom 2.
So I'm going to go second calc,
2.
2. Let's find this one first. So name a number to the left of where that crosses the
1.
x-axis.
0.
0. Name a number to the right of where that
2.
crosses. And what's our guess for that spot?
1.22. Yeah.
Okay, so it turns out 1.222 is one of our answers. And then to find the other one, I do the same thing. I'm going to find the zeros. So name a number to the left of this.
3.
3. Name a number to the right.
7.
Are you sure?
8.
So 8. I think that's right on 7.
6.8.
So then I guess you're going to go 6.8. Okay, survey says 6.87.
Which is 6.9.
Okay, so 6.871. All right, so they've got two different options there of how they can make their boxes, depending on, you know.
I have a question.
Yeah.
Why can't you just solve it by taking like 20 minus 2x equals 0 and then solve it for x?
Because 20 minus 2x does not equal 0, it equals 484.
So it should set it to...
But as soon as I subtract that over there and set it equal to 0, now since I have subtraction, I don't have this factored and I can't play that game anymore.
So you have to do the calculator?
So I have to do the calculator. Yeah. Okay. So what you asked is a good question. I was hoping someone would ask that. You can't do it right here because it's not equal to 0. And you can't do it right here because it's not all multiplication. So it has to be, in order for that factoring thing to work, it has to be all multiplication equal to 0. Okay? Gabe? No, again, because of this minus 484, that screws everything up. It has to all be multiplication for that to work.
I hate the calculator.
Okay, let's do one more with the regression curve.
No.
So we can do polynomial regression just like we did the other things. So on page 195, there is a table of U.S. farm exports
How do you want to say?
from 1991 to 1998.
You want to go 1 through
We want to go 1, 2, 3, and so forth. Bless you.
Thank you.
So the years are 1, 2, 3, 4, 5, 6, 7, 8. Okay, so you get all those entered in there?
No. Yes. We have to turn our plot on.
Yep, so now you go y equals, turn your plot on, and then go zoom 9, okay? And that's what your data should look like.
Whoa! That's no way.
What's the shape of that graph?
Well, it's a parabola and
It's a parabola,
and
but it's got a tail, right? Yeah, so it looks like it's a cubic because if I used a parabola, it would miss all this stuff over here. So a cubic lets me go up, back down, and then up again. So let's try a cubic. So go stat calc, and number 6 has cubic regression. And that's a pretty good R value. Yeah.
I have the right stuff, and I'm pretty sure I double checked it, and mine is not right. I'm gonna check my stuff too. I did.
So if you look at a graph of the equation that we came up for that, that seems to generally fit the trend there, right? This one's bad because it went down and that one actually went up, but other than that, it fits pretty well, okay?
How'd you
And
keep that
so,
line there?
what's that?
How'd you keep the line through there?
I just fixed it into Y1. And so you need to be aware that there's more than just linear and quadratic regression. You can do all kinds of different fun ones. And in your book, fun ones, in your book, on page...
Is all the stuff in there correctly? Nope. I don't know.
I'll help you a second for it.
I'd look for you.
On page, I don't know. I'll find it while you guys are working. There's a page in there that has all of the different shapes of all the different graphs. So you can pick from those.
Wait, we only have 5 minutes to work.
Oh, that
4 minutes.
killed us.
That's interesting picture. Is that 49?
No, it's greater than 9.
You can go get it from over there if you like.